Dear students, I have come with a new module, Introduction to Regression Analysis. So this is a continuation of correlation coefficient. Regression analysis and correlation are related concepts in statistics. Now we are going to learn this new concept, what do you mean by regression analysis and how we will compute that. So if you see the introduction, in correlation we have established that two variables are closely related. So in regression analysis, this is one step forward. That is, if we have established through correlation, two variables are closely related, you can predict the value of one variable given the value of other variable. For example, advertisement and sales. You know that companies, how they are forming their budget. Advertisement expenses, when they will increase, sales will also increase. When they will decrease the advertisement expenses, sales will also decrease. It is possible. So because we have established through correlation, advertisement and sales are related. If you want to compute the value or you want to arrive at one sales figure, you can predict the value of advertisement expenditure needed for reaching that value for sales. So this is the advantage of regression analysis. So regression analysis is the statistical tool used for predicting the value of one variable given the value of other variable, provided these values are related, and that we have to establish through the correlation coefficient. So this is used to, or regression analysis is used to identify the average probable change in one value given the value of other variable, and it is developed by Professor Francis Galton. Now we can see the differences between correlation and regression. Already I have told you that these are related concepts. So correlation, if you see the nature, in correlation we will establish that this will measure the covariability between the two variables, sales and advertisement expenditure, income and savings, income and expenditure. These are related variables. Whereas regression analysis is used to predict the value of one variable given the value of other variable. If you want to reach at one sales figure, what should be the advertisement expenditure? If you know your income, how much is your expenditure or how much is your tax? So that is possible with the help of regression analysis. Next is cause and effect relationship. So correlation is used to ascertain the degree of relationship between the two variables. Cause and effect relationship is not established in correlation. Please remember that correlation is only to measure whether two variables are related or not. Sales and advertisement, income and expenditure, income tax and income and savings, whether these variables are related, that we will establish through correlation. Whereas regression, once the cause and effect relationship is established through correlation, we can predict the value of one variable given the value of other variable. That is the use of regression analysis. So I told you sales and advertisement, how you can analyze what should be the sales figure. Then for that, what should be the advertisement expenditure or what should be the advertisement budget. So this we can predict only through the regression. So this is the difference between correlation and regression. Now we have to see that if you want to compute regression, there are two regression lines. So one regression line is called as regression line X on Y and second one is regression line Y on X. So regression line X on Y will give the most probable values of X for the given values of Y. So I told you always two variables will be there, income and expenditure, income and income tax or income and savings. Two values will be there. So one variable is there and the next variable you can predict. Similarly, Y on X will give the most probable values of Y for the given values of X. And there are two regression equations. We have two regression lines, meaning there are two regression equations. So regression equations are the algebraic expressions of the regression lines. Then you have to remember that regression equation X on Y is used to describe the variation in the values of X given the values of Y. Regression equation Y on X is used to describe the variation in the values of Y for the given changes in the values of X. Now regression equation X on Y, we have to learn the computation. So regression equation X on Y is expressed as X is equal to A plus BY. So you have to remember that Y is the capital Y. And I told you in statistics, small letter and capital letter, that's important. And you have to remember that. Then A and B are unknown constants in the equation. So to compute A and B, we have to solve two simultaneous equations. That is, sigma x is equal to NA plus B sigma y, and the second one is sigma xy is equal to A sigma y plus B sigma y square. Similarly, regression equation y on x is expressed as follows: yc is equal to a plus bx. Remember that x on y we are writing as a plus by. Y on x we are writing as a plus bx. And a and b are unknown constants, and these unknown constants are called the parameters of the line, that is parameters of the regression lines. So a and b are computed using the two simultaneous equations, that is sigma y is equal to na plus b sigma x. Second one is sigma xy is equal to a sigma x plus b sigma x square. For x on y, it will be sigma y square. Y on x, it will be sigma x and sigma x square. That is the difference, and if you remember like this, it's easy to remember the equations. Now, one problem we will do. From the following data, obtain two regression equations. Values of x 10, 6, 10, 6 and 8. Values of y 6, 2, 10, 4 and 8. Now, we have to see the solution. Values of x is there, values of y, xy is also there, and x square values we need and y square values we need. So, we have computed that in the table. And regression equation x on y, that is equal to xc is equal to a plus b sigma y. Two normal equations, sigma x is equal to na plus b sigma y and sigma xy is equal to a sigma y plus b sigma y square. So substituting the values in the equation, we will get 40 is equal to, we have already computed the values, 40 is equal to 5a plus 180b. This we are calling it as equation 1. Second equation is 260 is equal to 30a plus 220b. We are calling it as equation 2. Now, we have to make it simultaneous equations we have to solve. So, two values be made equal. So, how we will do that? Multiplying equation 1 with 6. So, we will get 240 is equal to 30a plus 220b. We are calling it as equation 3. The next equation is, we are not making any change. 260 is equal to 3a plus 220b. So, that we are calling it as equation 4. Now, subtracting equation 4 from 3. What we will get? Minus 20 is equal to minus 40b. So, we can cancel the minus signs on both sides. So, you will get b is equal to 20 divided by 40, that is equal to 0.5. Now, we have to substitute the value of b in equation 1. Now, we will get 40 is equal to 5a plus 30 into 0.5. That is 40 is equal to 5a plus 15. That is 25 is equal to 5a. That is 40 minus 15, you are getting 25 and 5a. So, a is equal to 25 divided by 5, that is equal to 5. Now, we can substitute the value of a and b in the regression equation x on y. That is x is equal to 5 plus 0.5 y. That is the capital Y. Now, we have to see that how you calculate regression equation for y on x. So, the regression equation y on x is yc is equal to a plus bx. Two normal equations, that is sigma y is equal to na plus b sigma x. Second one is sigma xy is equal to a sigma x plus b sigma x squared. Now, we have to substitute the values in the equation. We will get 30 is equal to 5a plus 40b. We are calling it as equation 1. Next is 260 is equal to 40a plus 336b. We are calling it as equation 2. Now, you have to make one value equal. Then only you can solve the simultaneous equations. So, you have to multiply the first equation with 8. So, you will get 240 is equal to 40a plus 320b. We are calling it as equation 3. Second equation is 260 is equal to 40a plus 336b. That we are calling it as equation 4. We have not made any change for the second equation. So, the same equation will be repeated as equation 4. Now, subtracting equation 4 from 3, we will get minus 20 is equal to minus 16b. So, we are cancelling the minus signs on both sides. We will get b is equal to 16 divided by 20. That is equal to 1.25. Now, we have to substitute the value of b in equation 1. We will get 30 is equal to 5a plus 50. So, this is to find out the value of a. So, that is 30 minus 50 is equal to 5a. So, a is equal to minus 20 divided by 5, that is minus 4. Now, you have to substitute the value of a and b. Because a and b are unknown constants, we found out the value of a and b. Now, you have to substitute these values in the regression equation y on x. That is, y is equal to 1.25x minus 4. So, this is what I want to explain with this module. Thank you.